Okay, we're about to look at question number 6 from the 2024 AP Calculus BC exam. This is probably going to be the series question. It has been for the last 25 years. Let's see. Yep, there it is. Good old series question to round up the AP Calculus exams. Let's see how this one goes. I have not looked at the question yet, so I'm solving these and processing them in real time. You can watch me process it. So if I make any mistakes, you can let me know in the comments and we'll address those. And this is probably going to be the most challenging question of them all. So this one, I may have to stop and think for a minute. So we have a Maclaurin series. Says it converges for all x on the interval of convergence. We'll probably have to find the interval of convergence. It can be shown that the Maclaurin series has a radius. Oh, they gave you the radius of convergence. That's nice. Determine whether the Maclaurin series of f converges or diverges at x equals 6 and give a reason for your answer. Okay, so if x equals 6, we have the series 1 to infinity of n plus 1 times 6 to the n over, I'm replacing the x with a 6, over n squared, 6 to the n. Those 6 to the n's will divide out. And we have n equals 1 to infinity of the series n plus 1 over n squared. That's going to diverge. And I can do a direct comparison. If you compare this, if you ignore that 1 and we compare this to the series n over n squared, which is the series 1 over n, I know that my harmonic series diverges. Okay, the series that that is some bad writing, but that says divergence. The series that I'm worried about is actually has a larger numerator. It's n plus 1 over n squared instead of n over n squared. Well, if n over n squared diverges and the series in question is even larger than that, therefore my series diverges if x is equal to 6 by the direct comparison or the basic comparison test. By direct comparison to the harmonic series. All right, so there's question A. On to B. It can be shown that f of negative 3 is that, and that the first 3 terms of this series sum to that, show that f of negative 3 minus the sum. Okay, so this is an error approximation. We do have an alternating series. We're on the interval of convergence at 3. Okay, I'll speak ahead to C and D. All right, so so I'm going to rewrite my series. How do I want to do this? All right, so my series is this: n plus 1 over n squared times negative 1/2 to the nth power, and we are starting at 1 to infinity. So if the radius of convergence is 6, negative 3 is within that interval of convergence. This is an alternating series. I'm afraid there's a lot of hoops we're going to jump through as far as meeting criteria to make certain claims, such as this is an alternating series whose terms decrease in absolute value to 0. And I think I'm going to go ahead and type this out. So this series is an alternating series whose terms decrease in magnitude to 0. And I know that it's an alternating series because I see the negative 1 to the n right here. We plugged in 3 for x. The radius of convergence is 6. And if the center is 0, that means we're going to converge from negative 6 to positive 6. 3 is within that interval of convergence. This is an alternating series. It does converge because it's on the interval of convergence. So I'm going to make that claim. I'm really saying all this just to feel better about what I'm saying about my work here. So the series is an alternating series whose terms decrease in magnitude to 0. Therefore, the maximum error in using the first 3 terms to estimate the series sum is the maximum error is less than or equal, this is wordy, equal to the magnitude of the first omitted term, which is the 4th term. That was really wordy. I got a little bit carried away on that. And that's what I was kind of thinking about earlier when I was talking about all the mess of this. So my 4th term is going to be when n is equal to 4, because they did say that S3 is the first 3 terms. And so this, there was f of -3, the function's actual value minus the series approximation using the first 3 terms is going to be less than or equal to the magnitude of my 4th term. And my 4th term, when n is 4, is going to be, so my error is going to be less than or equal to my 4th term. So I'm going to plug in 4. That'll be 4 plus 1 is 5 over 4 squared, which is 16, and -1/2 to the 4th. That ends up being +5 over, that'd be 16 times 16 is 256. And we are shooting to show that this is less than 1/50. And it is. 5 over 250 would be less than 50, and that denominator is slightly larger. So there is our error approximation on that one. You didn't have to clean this up. If you felt really good about what you've done up to this point, this line right here, that could have been omitted. You don't have to actually clean it up. So you can simply write that is less than 1/50 and meet the requirements of the grading, or I think you would. However, I do like to simplify it just so I can see that I do indeed have something less than 1/50. It makes me feel better about my answer. All right, number C. Find the general term of the Maclaurin series for f prime, the derivative of f. Find the radius of convergence for the Maclaurin series for f. Okay, now this is getting kind of lengthy, so I think I'm going to go to another page. I don't like scrolling down too much on these, so I'm going to go to another page and let's jump on to C, because we're about to have to do the, I think we're about to have to do the, are we good? Ratio test. And so let's see, so f prime of x, where's my pen? Here we are. So part C, f prime of x is going to be, let's see, so f is that original series, so it's going to be the series. If we're lucky, this will turn into a geometric series. Let's see what happens here. Now, I don't see it happen. N plus 1 times, and I'm doing the derivative of x to the n. That'll be n x to the n minus 1 all over n squared times 6 to the n, which cleans up ever so slightly. Yeah, this is not geometric. We're going to have to do the ratio test on this one. N plus 1 times x to the n minus 1 over n 6 to the n. Did I do that correctly? Find the general term of the Maclaurin series for f prime. Done. Find the radius of convergence for f prime. All right, ratio test. Limit as n goes to infinity of the absolute value of, and I'll plug in n plus 1. N plus 1 plus 1 is n plus 2 times x to the n plus 1 minus 1 is just to the nth, all over n plus 1 times 6 to the n plus 1. And then we divide by the series, which is the same as multiplying by the reciprocal, n times 6 to the n over n plus 1 times x to the n minus 1. And then we start to cancel this as much as we can. I'm going to change colors here so I can see a little bit better what I'm doing. Actually, I won't, because you can't change colors on the AP exam, I don't think. So let's see. I can cancel that 6 to the n with all but 1 6 down here. I have one more x on top than I do on bottom. So this is going to cancel with everything except the x. Nothing else reduces. The limit, by the way, keep writing the limit as n goes to infinity. The ratio test is indeed a limit. One of the things my students do that drives me crazy is they think all that's important is the algebraic work, and they don't write limit as n goes to infinity, and that can be held against you, and it should be held against you. Let's see. So addressing the absolute values, the only thing that could possibly be negative is the x. So I'm going to put absolute values around the x. N plus 2, 6, and n plus 1 times n plus 1 are all positive. So I'm looking at this limit, and the answer to this limit is going to be the absolute value of x over 6. We have the same degree on top and bottom. They're both n squared, so I divide the coefficients. And for the radius of convergence, I will take that, and I will set absolute x over 6. I need that to be less than 1 for this series to converge. X is less than 6, and therefore my radius of convergence is 6. I feel like this is going too smoothly. Have I misread something? I don't think so. I'm just looking over it really quick. Okay. All right. Now they've introduced a g of x, which is this thing. Use the ratio test. Another ratio test, really? Why do they have to assess our ratio testability so much? And they didn't even ask for the interval of convergence. It's the same. That's really interesting. They were really curious into how well you know the ratio test, which makes me think, did I do part C wrong? Find the radius of convergence for the Maclaurin series for f prime. It wasn't a geometric series, so we didn't have the option of looking at it from that perspective. I think we just have to do the ratio test. Oh, all right, ratio test it is. So limit as n goes to infinity of, and plugging in n plus 1, its absolute value, it'd be n plus 2, x to the 2 times n plus 1 will be 2n plus 2 over n plus 1 squared times 3 to the n plus 1 times, and then we reciprocate n squared 3 to the n over n plus 1 x to the 2n. And we start canceling. Let's see, I have 1, 3 left over in bottom. I have 2 more x's up here than I do here. So this is going to cancel all but the x squared, and that's everything. And for this limit, nothing inside can possibly be negative because that's x squared. N's and 3's are all positive, so we're left with x squared times n squared times n plus 2 over 3 times n plus 1 squared times n plus 1 is n plus 1 cubed. And I'm getting an answer to the limit again. Degrees are the same on top and bottom. So the answer to the limit is x squared over 3. And then to find the radius of convergence, I need to find out when x squared over 3 is less than 1. That's going to be when x squared is less than 3. And I'm going to solve this just kind of thinking about it. If I want a number squared to be less than 3, then I need that number to be between negative square root of 3 and 3 and positive square root of 3. And I almost accidentally went into the interval of convergence. I'm not going to test those endpoints because I don't need to. I simply need to know what the radius of convergence is. This is centered at 0, and we are going square root of 3 units in both directions. Therefore, the radius of convergence for part D is the square root of 3. And that is for the function g of x. And that radius of convergence is the square root of 3. I think I'm going to come up here and say the radius of convergence for f prime of x is 6. And I think we're good. I think that is all of it. Really bizarre to me that they asked back-to-back questions on radius of convergence. And I don't like that. It makes me think I messed up somewhere. And if I did mess up, you will let me know in the comments and we'll address them then. So that is it.